Happy Monday. Hopefully you had a nice weekend, got a little recharge or refresh. I know you guys are done. Probably even more so with this class. But you guys have a month left. Okay, let that sink in. You guys have a month left. That month, use it as an opportunity to get your grades up. Whether it's just at least to get passing grades so that you're able to have your graduation requirements to graduate, or if you're planning to go to college, you want to make sure you have those good grades because you guys are going to be juniors next year. Junior and senior year are going to go by so fast. Probably doesn't feel like it, but they go by really fast. So just make sure you're doing your best. I will be checking for missing or late work that was turned in between today and tomorrow. So I'll try to get that graded ASAP so that goes in your grade. Remember, tests and quizzes are 65% of your grade. Those are what can make or break your grade. Yes, still do your notebook checks because they will help your grade. But you want to make sure that you're doing what you can to study for those quizzes. You're doing the best that you can to study for those quizzes to do well. You don't have that many opportunities left. You're going to have a quiz this Friday on Molarity, which we're going to talk about today. And then Solute and Solvent that you guys learned about last week. I'll try to get up a review today, if not tomorrow. So you'll have that quiz on Friday. And then you don't have that many left in the remaining month. And then, of course, your final. So just make sure you're doing your best. I'm going to do my best to give you the notes and everything that you need. If something's not making sense, I need you guys to tell me, okay? With that gas law test, honestly, it shouldn't have been that hard. It could have been that I wasn't there to really explain everything, which made it more challenging or difficult to understand. I know there was a bunch of gas laws there, but that's why you guys were able to use your cheat sheet, and then later on, right, I let you guys use your notebook. So if something is not making sense, you have to let me know. For this test only, you guys will be able to do, again, test corrections. We're just waiting for a few more people to take the test, so you guys are able to do those. I don't know if that's going to be this week. Next week, you guys will be able to do redo those problems using your notes and then using people next to you if needed as a resource to get some points back. Okay, we'll talk about more what that looks like when the time comes, but you'll be doing test corrections, doing those problems for you to be able to get points back. So it's not like you're going to be retaking it to get full credit, but you will be getting points back. So it still is a great opportunity for you guys to increase your score by quite a bit. Okay, let's talk about this. Molarity. So, you don't have to draw this out. I'm just going to give you 2 examples here. Pretend these are mugs, okay? And we're going to say they're mugs of coffee because I need coffee. Yeah, babies as newborns get up like about every 3 hours. He's a really good baby though, and he will go back to sleep after he's fed, but getting up about every 2 to 3 hours is tiring, but it's okay. It doesn't last that long. And this one we're going to say coffee with espresso shots. Okay. I don't do extra espresso shots. I don't need them. I get jittery, but let's pretend we have coffee and coffee with extra espresso shots. If you're a coffee drinker, or you can relate this to any kind of other drink, whether it's, I don't know, lemonade, another Starbucks drink, whatever it is. But the point is, if we were to measure both of these, how do we know which one has more caffeine in it? How would we know? How would we measure how strong the solution is? In this case, right, we know that coffee is made using water. How do we know which one has more caffeine? We'd measure concentration. That is molarity. And with molarity, we're measuring the concentration of stuff or the solute in a solution, right? If you were to make Kool-Aid or make lemonade using the powdered stuff, right? How would you know how much of the powder is dissolved? We measure concentration. So, molarity. The definition of molarity. There's two ways that you can describe molarity. One of them is how much solute is dissolved in a certain volume of solution or you can say that it is the concentration of, remember, how much of something, if we're talking about chemistry and we're talking about substances, the how much part is typically in moles. Molarity, moles in a solution. And of course, if we're calculating concentration, what does that mean? We have a formula. Don't worry though, there's going to be one formula, not like 10 of them or whatever, how many you had for gas laws. So molarity, which is typically abbreviated in capital M, okay? Make sure you remember that. Just like for volume, it's abbreviated in V, temperature is T, and so forth. Pressure is P. Molarity is capital M. So we have moles of solute divided by liters of solution. So moles of solute, whatever is getting dissolved in the liters of solution, the entire thing. Okay. So moles, I was going to do a different color. Moles is amount of substance that we have okay, and the liters is going to be the volume the solution takes up. So if we're going back to that example of the coffee, right? The amount of caffeine, that would be the moles, right? So how much caffeine, the amount of substance that we have, moles of caffeine. And then liters, volume the solution takes up, it would be the whole thing. So whether it's a 16 ounce, 24 ounce, 32 ounce, whatever it is, that's going to be our volume. So let's do some examples. Oh, and really quick, make sure that whenever you're doing this, make sure that your units are always moles and liters, okay? Moles and liters. Make sure you're careful with that. So let's do some examples. Example 1. And yes, you have to write this out. The questions are not that long. They're not as long as they were, at least for the examples. They're not as long as they were for the practice for the gas laws. 2 moles of NaCl are dissolved. And this is going to be much simpler math too. So, and 1.0 liters of water. So we know that NaCl is salt, right? So 2 moles of salt is dissolved in 1 liter of water. So what do we do first? We identify what we have. All right, so we have, for moles, we have 2 moles right here. And then we have 1 liter of water, so that is volume. 1.0 liters. Oh, and I just realized this right here, the formula can be abbreviated to molarity equals mole over volume, or in this case, and volume would be in liters, okay? And then, what is the molarity? I forgot to add that here. Find molarity. So we know that we're going to be looking for M. So molarity is 2 moles over 1.0 liters. When you look for your answer, write your answer in, or you calculate your answer. Write your answer using 1 decimal point. So if you divide 2 by 1, you get 2.0 m. And that would be your answer right there. So all you're doing, just like you've been doing with stoichiometry in every single word problem, you're going to be identifying your given. Okay? Example 2. A solution contains 3.0 moles and 750 milliliters of whatever solution it is. What is the molarity? So what is the molarity? Again, we're going to identify what we have, right? So our moles, we have 3.0 moles. And I'm doing this to show you where I'm getting the numbers from. But of course, you're probably going to get to a point where you don't even need to write down the given, and that's fine. Or you're just going to plug it in the formula and solve. So we have our 3.0 moles. And then we have our volume. We have our volume, which is 750 milliliters. And they're asking us, what is the molarity? Okay, really quick. Remember what I said? You have to make sure you have moles of solute and liters of solution. You have to have both of these units for your variables for you to be able to plug them in. So what's the problem here? Our 750 milliliters is in milliliters and not in liters. So what are we going to have to do? Convert this. So we're going to convert this. We're going to do 1 liter, 1,000 milliliters, and we're going to get 0.75 liters. So let's plug that in. Moles on top, liters on the bottom, and we're going to get 4.0 m. So that means we have 4.0 of concentration of moles per liter of the solution.